in the year 1897, a physicist named J.J. Thomson made a very big discovery about atoms. While working in his lab, he found out that there are some things that are smaller than an atom. Let me explain the experiment to you so that you can follow me. If you imagine you have a long tube, and the long tube is plugged on both ends by metallic conductors, and the inside of the tube is completely evacuated. So the inside is a vacuum, nothing is there. And then you plug the two ends of the metallic conductors to electricity. If you do that, one end will become negatively charged, the other end will become positively charged. The negatively charged end is called the cathode. The positively charged end is called the anode. J.J. Thomson observed that when the electricity is connected across the ends of the tube, what seems to be a beam of light was flowing from the cathode towards the anode. And initially, he thought that beam is just light. But as a scientist, your thinking is not always what you believe it is until you have confirmed it. So, J.J. Thomson decided to confirm that this beam is actually light. As a physicist, J.J. Thomson knew that light is electromagnetic radiation. What does that mean? It means light has an electric field. It also has a magnetic field. The interaction of the two fields generates what is called light. Let me try to explain that to you with a diagram. If you have an electric field that is perpendicular to a magnetic field, the interaction of these two fields will generate what is called light. So light has electric component and magnetic component, which is why it is called electromagnetic radiation. So this is what J.J. Thomson decided to do. He brought a magnet close to the cathode ray tube. His expectation was that there should be nothing happening to the beam, because if it was light, a magnet should have no effect on it. Well, J.J. Thomson observed that the beam was bending in the presence of a magnetic field, which means it is not light. And that is not the only thing. The most important consequence of the beam bending is that whatever this beam of light is, it has mass. Let us begin to write the consequences of the experiment. It is a particle, which means it is a piece of matter. It has mass. It's a piece of matter. And because it can bend in the presence of a magnetic field, J.J. Thomson decided to try something else. What about electric field? So he removed the magnet and he brought two electrostatic plates, one that is positively charged, the other negatively charged. He brought them close to the tube. And J.J. Thomson observed that the beam was always deflecting towards the positively charged electrostatic plate, which indicates that the beam is negatively charged, because the law of nature says that unlike charges will attract. So, the second thing we can learn from this experiment is that the ray that is coming from the cathode is negatively charged. He then used both the magnetic field and the electric field to calculate the mass of the particle in the beam. He found out that the particles in the beam are about 2,000 times lighter than hydrogen. So, the next consequence of this experiment, the beam is about 2,000 times lighter than hydrogen, which is the lightest known element. This beam that was discovered from this experiment is now what we call the electron. This was the discovery of electrons, and one electron is about 2,000 times lighter than the lightest atom. The particles in that tube that J.J. Thomson originally called cathode rays are now called electrons. What is the takeaway from all of this? The takeaway is that an electron has a certain mass. The actual mass of an electron is now known. It is 9.11 times 10 to minus 31 kilograms. That is to tell you how small the electrons are. Electrons have a certain mass, and electrons are negatively charged. Please remember that. Electrons are negatively charged.